It's nice to be back here. I didn't know whether I was going to make it or not. I live right now in way down East Maine, and I fled the foot of snow behind me. And if I sneak back tomorrow, I'll get there before the next one. I'm a marine biologist, and I spent the vast majority of my career studying things that interested maybe 12 people in the world. And I loved it, because I love biology and I love ocean life and the spectacular beauty of it and the puzzles of trying to understand it. But about, oh my God, I'm 72, so maybe 35 years ago, I began to realize that everything I'd ever studied had disappeared or was on the way out. And that what I'd taken for granted as nature was something that my children would never see. And so I became very involved in issues, I'd like to say deep issues of ocean conservation, but always from the perspective of the fact that for some weird reason, I actually love the corals and the fishes and the sponges and the seaweed. And when I gave a TED Talk, which has the cheerful title of How We Wreck the Oceans, it was a kind of a lament for the extraordinary damage that we've done to ocean life. But around the last time I was here, I started to realize that although most people sadly don't share my affection for sardines and jellyfish, they have a deep affection for themselves. And that the threats to the ocean life that I love are, if anything, more dangerous to us than they are to the natural life of the oceans. And so this is a very different talk, because this talk, the last time I talked about overfishing and coastal pollution and climate change and poor corals dying and all that stuff. You can watch it on your website. But this time I'm going to talk about all the human beings whose lives are going to be placed in very severe jeopardy. And if you think about it, the crises, the global crises that are going to be caused by these events that are going to play out, and that stuff's sort of in your business. So let's start right out talking about Sea Level Rise 101. I think this audience knows all this, but you would not believe how many people don't know it, and that's terrifying. Sea level is rising because ice melts when it gets hot, and because water gets bigger when it's warmed. And the reason the Earth is getting warmer, as you all know, is because of emissions of carbon dioxide. So far, sea level rise has been mostly due to thermal expansion. So about this much, globally, the ocean has risen as the water has expanded, as it got warmer. But, at this point, it's really most about melting the ice on the land, and God only knows there's a lot of it. None of this is controversial. It was predicted by a guy I once met, and I spelled his name wrong. It wasn't Gustav. It was his father, Svante Arrhenius, who predicted exactly what would happen in his Nobel Prize speech in 1896. So this isn't exactly news. And sea level is rising a lot faster than we thought it would, which is the really sort of scary part. It only rose about 7 to 8 inches in the last century. It's done more than that, really pretty much up to now. The Intergovernmental Panel on Climate Change, which is an international UN group of distinguished climate scientists, makes projections every few years about how warm the Earth will get, how much sea level will rise, or whatever. And there's one thing you can say about them: they are consistently conservative. They always get it wrong. They've done so many IPCC reports that it's P less than 0.05 statistically that they will underestimate everything. You see that for sea level rise. The solid lines on the top are the real data. All the lines below in the gray stuff, which is the confidence interval, is the projection of the IPCC. These people have been screamed at for being radicals. They're conservative. They're always too conservative. And sea level is growing, is rising faster and faster, because what's going on is when we warm up the Earth, it's not just the temperature. We set off all these chain reactions of events. For example, it used to be in the summer, the Northwest Passage for hundreds of years. Nobody ever managed to sail across the Arctic Ocean in the summer. Now it's sort of a paseo. You can do it and sell tickets. And the ice is melting really, really fast, and it's melting much faster than anybody realized. We understand now why. It used to be the ocean, the Arctic Ocean was always white in the summer with the snow on top of the ice, and it reflected back the heat. But now there's all this melted ice and seawater below it, and the seawater looks black and absorbs more heat instead of reflecting the heat that the snow used to do. And so that heat, which is absorbed, warms the water even more, which means it gets warmer faster, which means more ice melts, which means there's more black surface, which means there's more heat absorbed, and blah, 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 blah. And before you know it, there won't be any ice there in the summer in 20 years. And then the other thing, which is actually like a horror movie, is that methane gas is bubbling out of the permafrost in the lakes and the seafloor of the Arctic Ocean. Methane is 30 times stronger as a greenhouse gas than CO2. And the thawing soils are getting warmer because there's more methane, which makes it get hotter, which means there's more and more and more. So these are positive feedbacks. And they're a real pain for climate modelers because they make everything nonlinear. But here's what it looks like. On the left, you can clearly see black and white. The more black, the hotter it gets. The more white, the cooler it stays. The white is on the way out. It's going to get hot, and that will be irreversible. And then on the right, you see in an Arctic lake this methane gas just bubbling up continuously. You can light a match to it. You're going to have it be a stove. And it's just coming out all the time in these vast quantities, and it's just going to keep doing that. And then that's the disappearance of the ice in the Arctic Ocean. I mean, there won't be any there very soon. Okay, so these positive feedbacks drive the modelers nuts because it's all about very complicated nonlinear dynamics, really difficult mathematics. And we empiricists, we boring empiricists, as opposed to the modelers, we keep finding new feedbacks. And then they have to go out and try to figure out how to incorporate those into their models. And as I said before, the IPCC scientists were not alarmists. They were too conservative. And that's really bad news for half the population of the United States of America because we lost 20 years that we could have been doing something about this. So how much will sea level rise? Certainly as high as the naval base at Norfolk and in San Diego, where I used to live. You guys are going to have to move. The latest IPCC projection, which is very conservative, is for about 1 to 3 feet. But what's really bizarre about this latest report is they say, we're only 2 and 3 confident that it will be within those limits. And that's just bizarre for modern science, because what you're saying is there's 1/3, 1 in 3 chance we don't know what we're talking about, and that it could be bigger. And that's the thing we should be worried about, because a 1 in 3 chance of a terrible outcome is a really bad thing. And I think this is really interesting about all environmental problems. You know, you don't like your face. You go to a plastic surgeon. You say, fix me. The guy says, well, you know, there's a 1 in 10,000 chance that you might die. And you say, I like my face, right? Or you put your kid goes out to walk to school, and somebody tells you there have been a lot of accidents lately. There's a 1 in 10,000 chance your daughter will die walking to school. You would not accept that. you'd go out and hire somebody to be at the crosswalk to walk your child to school. That common sense has not penetrated anything about the environmental policy of this country or any other country in the world. And it's time to catch on. So why is the confidence so low? I mean, we're really smart. We've got these satellites. We've got all this stuff. How can we be so wrong or so unsure? The problem is Greenland and Antarctica. 80% of all the fresh water in the earth is locked up in Greenland and Antarctica. If Greenland melted tomorrow, sea level would be 23 feet higher. Boom. Okay? If all of Antarctica will probably never melt, but if it did, it might be 100 feet higher. Okay? It's very unlikely that all of Greenland's going to melt in the next 100 years. Very, very unlikely, which is good news, right? But it's incredibly worrying that there are rivers, and I mean rivers, of meltwater pouring off of Greenland 24 hours a day. The West Antarctic ice sheet, and maybe a bunch of you in this room have been there, it's absolutely beautiful, beautiful place. Sort of down around the Antarctic Peninsula, that ice sheet is unbelievably unstable. It's moving, it's bending, it's burping, it's not happy. And my friends who go down there on cruises, they come back and they say, Jeremy, you would not believe what's going on down there. When it breaks, it will break. It will break suddenly, not gradually. It's not like Greenland with a mile-thick pile of ice. The West Antarctic ice sheet has its feet in the bathtub. That was fine as long as it was frozen all the way down to the ground. But now water's getting in underneath. And the water, so it's going to happen. And when that happens, it'll happen fast, and we'll see 10-foot sea level rise in a few years. And we ain't ready for that. I think we've got a few decades, but certainly no more than that. So there are a lot of people who are saying the hell with the IPCC, we're just going to do it. And this is an example of that. And so this is a very good paper. There are others. And what it shows in the graph is the distribution of probabilities of a particular sea level rise. So it's still the case, being conservative, that the peak in probability is somewhere around 70 centimeters. But look at this. Look at this broad tail out to 2.5 meters. And we call this kind of skewed distribution fat-tailed in the jargon of statistics. And so this means that, there's like a 5% chance of something really, really bad happening by 2100. Now we could all say, well, there's a 95% chance that won't happen. But think about your kid walking to school, and then that's not a very acceptable way to think about it. And if that happens, if that 180 centimeter happens, I'll come back to this, but goodbye Miami and goodbye all of southern Louisiana, for starters. And this was published in that distinguished scientific journal called the New York Times, a sort of a communist rag, I'm sure. But these data were provided by NOAA and the Geodetic Survey, so they're probably good. If sea level rises 5 feet, Miami Beach will be completely underwater. That's assuming there are nothing called waves or ripples or storms. Okay, New Orleans, 88%. Look at this. St. Petersburg, Cambridge, Mass, Harvard is toast, Yale is good. Okay, Virginia Beach, you're going to have to move that base, you really are. Miami, etc., and it works its way down. But all along the eastern Gulf Coast, 7 to 10% of it's going to be gone by 2100. And, that's where the rich people live, so maybe we'll pay attention. Okay, But, and this is where it gets really interesting. Oh, I don't want to blind you. It's really variable. So Galveston, Norfolk, and Atlantic City are way up there, in rises of 24 to 32, but look at Boston, much less, and LA is only 2. How come LA is only 2? Of course, it's because it's going up. They got earthquakes, we have sea level rise. It sort of balances out. And so there are all these things that are affecting that. The strength of the Gulf Stream is the best understood. The bedrock geology, uplift, there are places going up, right? Places going down, and severe storms. And these are what we're worried about. That's why they're in bold. Okay. So the Gulf Stream, it's getting warmer, so the Gulf Stream is pushing harder to the north. It used to be that the highest sea level rise along the Atlantic coast was south of Cape Hatteras. Now it's north of Cape Hatteras to here. Total shift because of warming and strengthening of the current. Bedrock geology. You do have some hard rock around here, so this might last a while. We got a lot of it in Maine, got a lot of it in Manhattan. That's why the skyscrapers are there. But everything south, New Jersey, all the way to Florida, the whole Gulf Coast is soft sediment that just erodes away. There are places that are going up. They're going up because of tectonics, like California, the Sierras, the youngest high mountains practically in the world, and glacial rebound. Stockholm is going up. There's a lock system so you can get to the lake beyond Stockholm, because when the Vikings founded Stockholm, you could sail out into the Baltic, but now the land has risen so much they have to have a lock for it. And this is Santa Cruz, really beautiful, Earthquake Alley. Look at the terraces, right? That's the land that's been lifted up in major earthquakes you don't want to imagine. They're not worried about sea level rise in Santa Cruz. But subsidence, I don't know if any of you are from Louisiana. The whole East Coast is sinking. It's sinking because it's a passive margin. The Atlantic is widening. It's slowly falling down. We can live with that. But deltas are nosediving down. 500 million people in the world live on deltas. Think Cairo, think the Ganges, think New Orleans. And the reason the deltas are going down is because we built all those dams upstream to make electricity we didn't need in North Dakota. And so all the mud, which is filling up the lakes behind the dams that they don't know what to do with, was supposed to go to New Orleans to keep the delta alive. So it's starved of the sediment it needs. And then the other thing we're doing is we're extracting humongous amounts of fluids from that delta, right? It's called oil and gas and water. And nature abhors a vacuum. So when you take it out, it's got to sink. All those earthquakes in Oklahoma that were in the news last week, they're from fracking. I mean, you take these vast amounts of fluid out, the land goes boom. And then the other thing that's weird about New Orleans is all the sediment is organic. You expose it to the air, it burns in the oxygen, and it disappears. The land literally oxidizes and disappears, so it's not good. The Mississippi Delta is big. 60% of that delta is less than 2 meters. 2 million people live on that delta. 1/3 to 1/4 of the wetlands are gone forever. And the thousands of miles of channels for laying the pipelines are erosional. So they start out this wide, and they're now as wide as this room. And they're like tumors. They just grow and grow and grow. So the whole delta will be gone by 2100. That's not an exaggeration. that might even be conservative. And then, of course, there's storms, there's waves, there's Katrinas and Sandys. I think you know all this stuff about hurricanes, but I guess the really important thing to remember is a hurricane is a heat engine. The whole energy of the storm comes from the heat that's released when the water evaporates, when the sea is sufficiently warm, and then that goes up, right, as rain, and it goes up as water vapor and comes down as rain. And it's like a dynamo. I mean, it just keeps going and going and going, as long as it has heat to feed it. And the strongest storms are ours. In the whole world, the strongest hurricanes or typhoons are in the North Atlantic. They are really strong. I was in that strongest one, Hurricane Allen in Jamaica. And Katrina and Sandy were among the 3 or 4 costliest disasters in our country since World War II. And the worry is that they're going to be stronger and stronger because of warming, and how much will that cost us? There's a huge scientific argument about this. I don't want to really bore you with it. The hero of stronger hurricanes is this great guy at MIT called Kerry Emanuel, very, very charismatic person, and he defined what he called this power dissipation index, in which he pointed out that a very small increase in maximum wind speed will result in the cube of that increase in damage. So the damage will be much higher than the very small increase in wind speed. People don't want to believe him. It's very controversial. And then a bunch of quiet, sort of dorky modelers sat down and said, oh, you know, it's right. And we're going to see this modest but real increase in the power of hurricanes, and what's actually maybe more worrisome, a lot more rain. So storm surge, and I don't know how many of you know the geography of New York City. That's my hometown. But storm surge is the real evil in hurricanes. And it's particularly bad wherever the water's shallow, around deltas, or where the geometry of the coast more or less dooms the place. So Long Island Sound is 25 kilometers, 15 miles wide in the east. It narrows down to about 3 kilometers at LaGuardia and Co-op City, to about 1 kilometer or half a kilometer in the East River at the Brooklyn Bridge. So think about all that water was driven into Long Island Sound. And it was like the Bay of Fundy, the tides of the Bay of Fundy. There was nowhere to go. And so the only place the water could go, because there was this huge force pushing it, was to go up and up and up. And the net result was what we all know from Sandy. Now, Emanuel said it was the cube, but there's this fascinating economist at Yale named Bill Nordhaus, and he wrote a book called The Climate Casino, and he's probably the economics expert on hurricanes and implication of climate change for coastal cities, and would be a very cool lecturer, actually. And what he did was go back and look much more carefully as an economist at what Emanuel did. And so he determined the wind speed of every hurricane and the damages that occurred, and as an economist, he had access to that kind of data. And he concluded that the damages from storms occur at the 9th power of the wind speed. I mean, that's scary. And his explanation for it is that Emanuel just thought about wind speed. He didn't think about surge, and he didn't think about rain and flooding. He was just thinking about wind. And also he wasn't thinking about the fact that the stuff we build is more and more complicated. If too many people get in the Washington Metro at 5 o'clock in the afternoon, the car sags and we all have to get out because the train can't go, you know. Somebody over-engineered that system. The Twin Towers fell because we exceeded their tolerance. And he thinks that in a more mundane way, that's why these storms have such a catastrophic cost. He also thought about those fat-tailed distributions in the context of Sandy. And I went and I interviewed him, and we had this fascinating conversation. And he sat there and he talked to me about what he called existential events. When we have events that happen that are beyond our experience, and all our rules break down. All of our notions of risk and the rest of it. And he made this analogy to Germany in the summer of 1945. And the thing that's really disturbing about that, because, you know, Katrina was sort of like that on a smaller scale, is that in Germany, they still had the land. But with sea level rise, there won't be any land. So when the catastrophe happens, the homes, which can't be moved, are gone. And so it becomes really, really hard to imagine. And he asked his students this great exercise. You guys should do it here. You're the president of Yale. You're pretty lucky. You're, 30, 40 feet above sea level. So it's not so bad. What would you do in 3 different scenarios? The first one is the tsunami of all tsunamis is coming in 30 minutes. What do? You abandon ship? As Nordhaus put it, the students won't leave without their laptops, but you run. Maybe you have a forecast. Really smart people at NOAA come and they tell you sea level is going to rise, those 10 feet because of Antarctica, the West Antarctic ice sheet breaking up. It's going to happen in 10 years. What do you do as the president of Yale? Their art collection is worth many billions of dollars. You move it out. You move out the mass spectrometers. You move out everything that's worth a lot of money. You go away, you get a bunch of Quonset huts, you run the university, and then you come back and see whether it was really true or not. But the third thing, which is really relevant to the country, is you're confronted with the virtual certainty that Yale will be underwater in 200 years. What do? Do you wait for 195 years? The way we're doing things right now, that's what we do. But you don't do that. And when you think about it, you think about, do I just go to Hamden, someplace a little higher? Or do I say, the winters really stink in New Haven, and maybe we should move Yale to, New Mexico. He's from New Mexico. So we need to do this kind of thing. We need to do this kind of thinking. And the rest of the talk is going to be about that, because 1/4 of the population in this country is going to have to make that decision by 2100. And hopefully we'll do it intelligently. And that means 3 things. We got to go to school. We have to assimilate and understand the scientific information instead of saying it's not true. And we have to make an objective judgment of the relevance of that information to where we live. And then the third thing we have to do is be willing to act on the information, even if we don't like it, right? So that we can do something rational for our own well-being and our neighbors. So here's the way I think about it. I made up this stupid little equation. The fate of a people or a place, the fate of the Naval War College, will be a function of the magnitude of sea level rise, the local extenuating circumstances, I have no idea what they are here, the cultural and governmental capacity to assimilate the information. Well, you guys are great at that, but travel 50 miles and it might be a little different. And then the cultural and governmental capacity to act meaningfully on that data, to do something about it. So the fate of a place is equal to global change plus global circumstances plus the capacity to understand and the capacity to act. And I know that's really abstract, But what we're going to do is we're going to make it real by talking about 3 cities. New York. I'm from right there. It's the 3rd most exposed city worldwide to just a couple of feet of sea level rise, according to the OECD. These numbers have changed a little bit. All those new cities in China built on landfill, 2 feet above sea level, they're going to be the tops. But 2007, there's about $2 trillion in exposed assets and 3 million exposed population with an elevation of 6 feet. And that's what it looked like after Katrina, before that sea level had risen, right? That's the subway at the World Trade Center. That's a lot of taxis. That's a tunnel that, thank God, they didn't get all the way in. And that's, out on Long Island. Because there are waves. So what's the scenario for New York? New York gets it because they have the bitter pill of Sandy. Bloomberg stood up 2 days later and said, I was wrong. I was underplaying the importance of environmental issues for the city. Mea culpa. And there are a lot of discussions. There have been art exhibits in the Museum of Modern Art of parks and wetlands to be built in all the low places so that the city could still be beautiful and how it would adapt. So it's a really good start, but hey, nobody's doing anything, right? I mean, like zoning, people can still build on those barrier islands. They're going to have to move LaGuardia and Kennedy. That's not a small issue. And fortify all those subways and tunnels, but they'll do it. Maybe it's because I'm a New Yorker, but they're so goddamn wealthy. And Wall Street is so powerful. I mean, half the money that was donated in the last presidential campaign, 1/3 came from the Upper East Side. They'll fix it. And so they'll buy 100 years. But they're lucky. I mean, they've got bedrock. They're relatively high, and they still probably only have 100 years. So now let's go. I grew up here. I'm from New York, but I grew up right about here in the highest place in Miami-Dade County, 13 feet above sea level. Miami is the most exposed city in the world, according to the OECD. The average elevation is just a meter. There's $3.5 trillion in exposed assets, 5 million exposed population. And Tampa and St. Petersburg are the same. So if you combine them, it's like 10 million people and $10 trillion exposed. Miami is only 20% flooded, but notice that Miami is 2 islands with nowhere to go. And the water coming up their butt. Right there. Because all of this that was the Everglades is now Florida Bay, which extends to Lake Okeechobee. You're from Florida. I took this with my iPhone. I'm very proud of this picture. I lived in a hotel there. I went to 1st grade in South Beach Elementary School. And then I moved there. And I went to high school in the 50s, and when I was there in the 50s, it was against the law to build homes on Key Biscayne and all these places because everybody knew that when a hurricane happened, the waves broke 10 feet above the island. But a guy named B.B. Rebozo fixed that. So there are now all these people connected by the same little causeway that was there when I was a kid. All of these islands, you will notice from the natural rugged coastline, are landfill. All of these new skyscrapers are built on landfill. All of them have their feet less than 3 feet above sea level, and they're toast. And if it doesn't get you from the ocean, it'll swallow you up. Because Florida is a limestone platform like the Bahama Banks that was slightly uplifted, and limestone dissolves. And so, that was a PBS program. This poor guy was sleeping in his bedroom, and he disappeared. 100 feet down, they never found him. That's a big resort up north in the lakes. This happened in about 3 days. It's happening everywhere. There's now a sinkhole alert network. I don't want to retire there. And this is a map. Look at this, a map of the sinkhole zones of the state of Florida. So it's being sunk from outside and it's dissolving in the middle. So what's going to happen in Miami? There's going to be massive inundation. Saltwater intrusion is inevitable. In 1953 or 4, in a stupid little Category 2, on our property, which had a sinkhole, the water in the sinkhole rose and fell from the surge created in the groundwater by the force of the storm. And that was a Category 2. So the groundwater will be poisoned and all of that. Florida is an outlaw state. They are encouraging the building of these new buildings on landfill. It's official policy. And when the insurance industry, when the reinsurance industry, which I think runs America, said, we're not going to insure any more homes, they said, we'll insure them. Well, that's great, right? There's no money in Florida to pay all those people. There are no realistic evacuation plans. Key Biscayne, a causeway, 100,000 people. And they're the kind of people who say, I'm tougher than any hurricane, until they get scared to death, right? And you can imagine the traffic jam. So what we're looking at, and I think I said this when I was here 5 years ago, is 5 million climate refugees and the bankruptcy of one of the most important states in the Union, in the richest country in the world. It might take 20 or 30 years, but it could happen tomorrow. A real Category 5 like that super hurricane that destroyed the Flagler Railroad and just erased whole parts of South Florida. Okay, and then there's New Orleans, which I've spent a lot of time there now, and I've been in all these places, and I love the people, and it's just so much fun. But oh my God, they're at sea level or under sea level. You realize, and I mean, it's just, you know why we protect it. We protect it because of Chemical Alley. The entire petrochemical industry of our country has the refineries, the first stop refineries are all along here, and you go down the river and it's really interesting. And you see one chemical plant after another. The locals call it Cancer Alley. More sophisticated people call it the American Ruhr. But it is one of the most valuable and important places for the US economy. And it can probably make it, but not these people. So, most of the Delta in New Orleans are at or below sea level. The Mississippi River, anybody who's been there, you know, the river flows 15 feet above the streets because of the levees. Subsidence is so fast that an acre of Louisiana drowns every hour. You project that out, that's more than 35 square kilometers per year. That's 1% of the area of the Delta is disappearing every year, and we're measuring it. This isn't theory. This isn't Pinko, whatever. This is just data. Most of the locals actually get it. Half of them didn't come back. And when we interview people and we ask them, do you want your children to do what you do? They say, no way. We could sort of hold it off a little bit. We could spend another 10 or 20 billion dollars or something, and we could make the oil companies fill the channels they made, and we could build another system of levees that might work once. But there's really only one logical solution, and that's to take all that wonderful culture and those wonderful people who are attached to their homes and uproot them and hopefully move them as a community to some place where they will be safe. And then just keep the city as a transfer station. I mean, you only need 10,000 people to run it as a port, and just forget about it. Economists will tell you that privately. I've talked to 3 different economists who said that is the only logical thing to do with New Orleans. It doesn't play well politically. And there it is. I mean, look for yourself. They talk about the highway to nowhere in Alaska, but this is my favorite highway to nowhere. It goes to a fishing village. It cost a lot of money to build. All of this 10 years ago was above sea level. All of it. That's an island where a bunch of people still live. It's got 10 years. That's their graveyard. And that's a cypress forest, because the cypress forests are sinking as well. Okay, what does all this say? Sea level rise is going faster and faster. It's going to go on for centuries until most of the ice is melted. We'll probably never melt all of Antarctica, but the rest of it will go. The train left the station. We're committed to at least 3 degrees of permanent global warming for the next 10 or 20,000 years, which is sort of beyond my ability to think. So it's real, it's happening, and it will follow its course to conclusion. So the retreat from the coast is inevitable as the land drowns. And you know, it's really bad and it's really scary, but we're a smart country, we're a rich country, we're a resourceful country. We can handle this. But the only way we can handle it is if we wake up to the realities and begin to think about how we're going to act on it. There's a lot of really good stuff we could do in the short term as long as we understand it's only for the short term. And we just got to move fast. Because if we don't, we're going to kill lots of people. And we're going to throw away trillions upon trillions of dollars. That made my day. I realize it's a pinko newspaper, but the New York Times and Stanford University say that they have very clear results that the majority of Americans want government action on climate change. That is like such good news. And that includes half of all registered Republicans. So, it does. Hey, you know, that used to be the environmental party of this country. It sort of morphed. But the Clean Air Act and the Clean Water Act and the Endangered Species Act were enacted under Richard Nixon by his assistant, the man who founded the World Wildlife Fund. I mean, there are enormous Teddy Roosevelt national parks. This shouldn't be a political issue. This should be an issue of government and supporting people. So the hard part is going to be to adapt, right? I mean, they want us to do something about climate change. Well, we can't do very much about what we've already done. We can just make sure it doesn't get even worse than what we've caused. And that's going to be hard because it means that we're going to have to give up a lot and adapt to a lot of really serious change Stop going to Florida to retire. You can go to California, they're going up. Florida's going down. Thank you very much. Okay, if you want to get home before the snow. I have a foot coming, so. Anybody? I really, really made you feel good, right? There's somebody back there.
Sir, Major Eric K. United States Marine Corps. Whether your politics are left or right, I agree with the data, sir. Data is the data, you know. And as a scientific-minded person myself, I have two questions for you. Number one, what is your opinion that the scientific community could be wrong with their conclusion that climate change is human attributed? And number two, what experiment could be conducted to prove or disprove the hypothesis that climate change is human attributed?
Well, we're doing the experiment. We're doing the experiment because we're putting more and more rather than less and less carbon dioxide in the atmosphere. You could say it's an N of 1, but that's sort of silly. I think the way to think, I tried to say it very gently in my 101 slide. A famous physicist at the end of the 19th century wrote a paper predicting exactly what would happen because it was high school physics. The only reason we doubt it now is because of the implications for our way of life. But it wasn't controversial until about 30 years ago when my former colleague Dave Keeling, who measures, he died recently, but the Keeling curve of carbon dioxide increasing from Mauna Loa, Dave built the instrument to measure that. He was hired by the great Roger Revelle, brought to Scripps to do that so that Roger could balance the carbon cycle. It was just, straightforward atmospheric physics and chemistry until somebody in the Department of Energy said, oh, you mean we can't do that? And then it became politicized. So that it never was a political issue until relatively recently. And, in science, you never prove anything. In science, you try to falsify what you know. And you keep trying to falsify it. And if you keep failing, you get to the point where you're really bored. And then you call it a law so that everybody can forget about it and move on to something else. Greenhouse warming by greenhouse gases in the atmosphere is at the level of a law. It agrees with everything we know about how things work. What was your second question?
Thank you for your opinion, sir. The second question, you kind of alluded to it, but it doesn't seem like you can quite possibly do it, is what experiment could be conducted to prove or disprove the hypothesis that climate change
Experiments are meaningless unless they're done at the appropriate scale. We only have one Earth. So you can't have a control unless you want to make an atmosphere on Mars. You could do a dinky little, you know what the experiment is? Every greenhouse in America, right? The greenhouse works because of what? Because the sun shines in and it can't get out. CO2 is a greenhouse in the atmosphere. Energy comes in, a lot of it can't get out. As we increase the amount of CO2, it's going to get warmer. It's going to do exactly what you could do in a little experimental chamber where, you created a little fake atmosphere and everything, but I mean, no scientist would do that. I mean, it's just not worth doing, because that's like saying force equals mass times acceleration. It works, right? Artillery works because of classical mechanics. This stuff is what we've been teaching children forever. And so, and besides, if somebody doesn't want to believe it, they're not going to believe it. Look at the, I said I wouldn't talk about this, but look at the vaccine thing. Holy moly, you know, I mean, vaccines work. They do not cause senescence and Alzheimer's disease. They saved 1 million lives. We have a measles epidemic in this country because of a denial of basic scientific information. And we didn't do anything about global warming because of a denial of elementary scientific information. And I think that that poll I showed, that 2/3 of Americans want a president who will do something about climate change, says the discussion's over. Anybody else, or are we done? Come on, it wasn't that bad. Somebody there.
Sir?
Oh, I'm sorry, and then you.
That's okay. Keith Maloney. Let's say you're the big guy in the world right now. You make all the decisions. You said to some degree, if I understand you correctly, that we can't go back. So in the case of New York, New Orleans, and Miami, should we just accept where we are and start moving the place? Because there is no going back. It's going to happen. Or can we reverse it to the point where moving those cities and those resources is not an absolute necessity?
Well, that's a really good question. I'm afraid the answer is that it really looks like we're committed to 3 degrees. And there's all this inertia in the system. And it's not going to dissipate for a long time. The carbon dioxide that's in the atmosphere will eventually mix into the ocean. And the pH of the ocean will return to what it always was, around 8.1. The carbon dioxide concentration in the atmosphere will return to what it always was. It's a kinetics problem, because the ocean can't devour the CO2 fast enough. After all, the ocean only mixes vertically on a time scale of 1,000 years. So to get that stuff down and buried where it can interact and be absorbed is going to take a lot of time. So if we're genuinely committed to 3 degrees, and there are a lot of people who say 4, then sea level's going to rise at least 10 feet. It just is. Probably 20, 25. But it's going to take a long time. And what I was trying to say, and I hope it got across, we shouldn't abandon New York tomorrow. You know, New York's got 100 years, and we can slowly sort of jump over the meadowlands to someplace more attractive. They will be underwater. They will be gone. Miami is hopeless. Miami should be abandoned. I mean, how many of you have been in a bad Category 5 that stalled for 48 hours? I have. I mean, the noise is so loud you can't hear yourself speaking. You can dump. Hurricane Mitch dumped 1 meter of rain in Belize in 15 hours. So there's just no hope for those people. I mean, it's tragic. You know, it's the retirement dream, it's all that stuff, but they ought to go. And then, as I said about New Orleans, they get it. I mean, there's a huge culture. I hope I'm not being disrespectful about that. There's this one of the most remarkable cultures I've ever had the privilege of enjoying in my life in the Delta of Louisiana. Those people are extraordinary. They love where they live. And they're going through a personal catharsis trying to think about this. But they know one thing, they don't want their kids to stay, you know. And so the old folks, if they want to stay, why not? But there's no future in it. I mean, I went to hustle money for my book with a guy at the Baton Rouge Foundation, which guess where it is, and guess where their money comes from. And he asked me what my book was about, and I knew I wasn't going to get any money, so I said, my book is about the fact that the Gulf of Mexico will be lapping up on the streets in Baton Rouge in 50 years. And he said, we know that. Well, think about that. There's sort of a cynicism there, you know? So there's this discussion going on, but it's going to have to go. But why not make it a port? 10,000 really good engineer, port-type people, houses built on 25-foot tall concrete, steel reinforced pilings. They can ride it out. They can be helicoptered out on a moment's notice. And they can run the incredibly important Port of New Orleans. But people shouldn't live there. They just shouldn't. And we're just going to have to figure that out. You were over there.
Good evening, sir. Colonel Mike DeRozier with the U.S. Army. I'm curious if you are encouraged or discouraged by the political response to Hurricane Sandy at the federal, state, and local levels.
That's a really good question. I'm on the Scientific Advisory Board of NOAA. And we talk a lot about stuff like that. We're doing a strategy review right now about, we know they do the science well. We know the observational systems are amazing. I mean, I don't know if you noticed, they predicted the flurry of tornadoes in Oklahoma 24 hours out. They predicted the exact track of Sandy 5 days in advance, and it was on the web. They're good. What they will tell you they're not that good at, and it's a struggle, everybody struggles with it, is how do you get people to listen? How do you get people to understand? And so on the Scientific Advisory Board, we believe that the biggest challenge that NOAA faces is in the socioeconomic realm, not in the scientific realm. That there needs to be a kind of translation service to intelligent people. I mean, all that stuff in my 101 slide, 95% of Americans don't know that, including all the people with PhDs from Harvard and Yale, you know? I mean, it's just appalling. And so it's a steep curve, and NOAA, that is, so the Kathy Sullivan, the new chief administrator, she talks about a weather-ready nation and a more resilient nation. And her concept of resilience is very much in the socioeconomic realm. So getting back to your exact question, it was great. Everybody got it. I mean, they saw what happened. There was this amazing scientific paper that predicted exactly, talking about experiments, that's an experiment. Somebody publishes a paper and says, when the next really bad hurricane comes from the east and homes in on New York, it's going to be flood city in New York because of the funnel effect in Long Island Sound, and exactly what was predicted happened. And Bloomberg listened, 2 years too late, but he listened. And so, yeah, I think it was an incredibly important first step in establishing a respectful conversation among the different parties. Yeah.
Hi, sir. Phil Weiskup. So if I understood correctly, there is something that we really need to watch for, and that's this ice business in Antarctica. So what's the name of the place? Because I saw a YouTube video that showed, it said the largest calving event ever in history. And this is in the last 6 months. So what's the place that you know, normal people need to know that if this happens?
Well, you know, this is really difficult for responsible people because you really don't want to cry wolf. And I sort of brushed over it for time, but, you know, how do you model, to be fair to the IPCC, you've got a mile-thick pile of ice on Greenland. You can't X-ray it and see all the way down. Some satellites get pretty close, but you can't really do it. You know there's torrential rivers running off at the bottom and at the top, and it scares you. But it's probably still a drop in the bucket compared to that mile-thick pile of water. On the other hand, if it melts too much in the bottom, it could slide off, right? So all that stuff's going on in your head, and so the high-precision modelers say, I can't deal with this, and so they don't. That's okay. West Antarctica is a much more tractable problem. And I think the key issue, we know that the last ice age, we came out of the last ice age in like 100 years. So imagine a world with mile-high piles of ice in Scandinavia and Canada and where I live in Maine, and all the way down to Long Island is the terminal moraine, right, of the ice. And in 100 years, it's flipped. And a colleague of mine at Scripps, a guy named Wolf Berger, wrote a paper about how he believes that the reason that happened so fast was because the ice was under sea level, and when seawater got in, it just took off like that. Well, there's seawater under the formerly fully grounded West Antarctic ice sheet, and so, yeah. I think we would have a couple-year warning, but a couple-year warning for Manhattan is, we got to watch it. Yeah. You guys are down there all the time. I saw you when I was there. I went as a tourist. I never managed to get a free ride, so I went as a tourist. Anybody else? We're done? Oh, sorry. I can't see. Well, it'd be worse for you because you guys live so high above sea level, you don't have anything to worry about. Your fjords will just get a little bit deeper.
Maybe increase the ice levels in the Arctic region again if something happens to those.
Oh, I'm not a physical oceanographer, so I very carefully read the article about the change in the Gulf Stream. The Gulf Stream, of course, is born in a very warm area, and so warming it up more makes a lot of sense. How much that would affect anything on the other side of the pond when it pushes its way across, I don't know. You people have the best fisheries biologists in the world, and I'm sure you've got it all figured out. in the Bering Sea, we're seeing fish stocks that we used to rely on being replaced by other fish stocks. I don't think it's clear that we have a lot to worry about that. We'll just eat different fish if we don't overfish them. But the movement of the current, it's pretty interesting, right? The Gulf Stream has been there for a long, long time in a very stable configuration, and it is on the move. So where it's hammering our East Coast the strongest used to be in sort of South Carolina. And now it's up in the mid-Atlantic states and even up into New England. Of course, it's carrying more heat because it's got more heat from the beginning, but I don't think Europe has to worry about that. You have to worry about your heat waves further south, but Norway is in a wonderful position. That's why I live in Maine. Okay. Thank you all. I hope that.
If you don't mind, a couple of quick comments. So thanks very much for what I would offer was both a stimulating and impactful presentation tonight. I think as you were presenting, I was thinking about it a little bit. I think stimulating maybe in two terms. As you know, we study strategy and security issues here. And I think over the course of your presentation tonight, in terms of strategic thinking, you know, what you've laid out are some of the challenges we face in properly valuing a potential future in terms of decision making today.
Oh, the Navy's going to have a big role. I mean, the first time I came here, at your invitation, I did my little Miami scenario, but what I had been really impressed by was I've done a lot of work in the Caribbean. And when that horrible earthquake happened in Haiti, the Navy could go in and sort of take care of stuff. You can't do that for Miami. I mean, the scale of it is so vastly greater. And I think we're also used to thinking about it in other countries and not thinking about it on our own territory, and how we're going to have this very different situation about having to handle crises that we think about being out there somewhere on our own ground. So I hope you all do that. Do it well, do it well.
And the presentation was, just as you were just alluding to, maybe a little U.S.-centric tonight. And the challenges that you talked about tonight are going to be challenges faced across the globe with respect to cities and mega populations.
I did that deliberately. I thought, I mean, with a different audience, I would make it more global. But from a security point of view, think about Bangladesh. The huge proportion of people who live on the Delta. They're boxed in by two countries that are building walls to make sure none of them escape. And half their country is going to disappear. And it's going to disappear in catastrophic storms. And are we going to turn off the TV so nobody can watch? I mean, what's going to happen? It's going to be horrific. And there are a lot of those. Guayaquil is another Miami, and it's growing so fast, it's just as many people. It's built on fill on mangrove swamps at sea level, and on and on and on and on. So yeah, lots of work in the future.
Well, thank you for, again, stimulating, and as one minor example of the impact, Aaron just informed me of the change in our retirement plans from Cape Hatteras to Asheville, I think, in North Carolina. So on behalf,
you do not want to live on the Cape.
on behalf of the college, sir, thanks again
Oh,
for
you're very
chatting with
welcome.
us and stimulating our thinking.
Okay, excellent.